Okay, so this is a pretty good place for me to follow because I can skip some of my descriptions of EPAS because you all know basically everything about it. That's not fair, but you know enough to know what I'm talking about. So I'm going to be presenting some current results of statistical analyses that myself and Jason have conducted on the sort of some of the questions that underlie this model of the Neo-Assyrian landscape as a planned landscape. And actually, this is the Zaga Canal, which is one of the major landscape alteration features that Jason talked about. So there's going to be two focuses for this presentation. First is on changes in settlement patterning in northern Iraq during this transition from the late Bronze Age to the Iron Age, and then the second is on the utility of statistical methods when analyzing these patterns. So, after providing some brief historical context, I will discuss the opportunities and challenges involved in a statistical approach. I'll follow that with an overview of our current results, and I'll conclude with a discussion of how this research will continue to develop as it moves forward. So as a little bit of background, just the Neo-Assyrian Empire ruled an enormous swath of Southwest Asia during the 10th to 7th centuries BCE, with its political center in Upper Mesopotamia. The empire engaged in a program of mass deportations that moved conquered populations from one side of the empire to another. These groups were placed in settlements and cities to work as laborers, craftspeople, and agriculturalists. Many of these populations were brought to the imperial core. A lot of the primary textual sources give a lot of attention to the role of the deportees in the Assyrian king's monumental construction projects, but there are also records of the creation of deportee villages in fallow lands. This is a section of the Bull inscription which reads, Sargon II set his mind to resettling the abandoned outlying districts and cultivating fields left fallow. Obviously, we shouldn't always trust texts, but you know, it's a place to start. So our analysis is designed to determine the ways in which settlement patterns change during these periods and to link those changes to the historical narrative where possible. So this is that model of planned agricultural colonization that Jason talked about, and sort of the questions then are what would we expect in terms of the very basic patterns, not necessarily even the higher level interpretations. So this would be increased regularity in settlement spacing. It would be an increased regularity in settlement territorial area, being the sort of agricultural exploitation area, and then an expansion into areas with less natural access to water, further away from natural drainages. So this model has been examined in many ways, textual, landscape, historical, but I think this is the first time this data set has really been given any sort of statistical analysis. There are two data sets used in this. The first is the EPAS data set over here, and then the second is Tony Wilkinson's North Jazeera Project survey data set, which is over here. So either side of the sort of imperial core, the four capital cities, well, within the core on either side of the four capital cities. For a little background on the North Jazeera Project, it's a 475 square kilometer survey in a shallow basin drained by the Wadi al-Mur, heading down towards the Tigris. It was an intensive service survey and then supplemented by analysis of aerial imagery. Okay, I skipped my EPAS description, but then there's also elevation data involved in this, and that was provided by the Shuttle Radar Topography mission. So, what are the reasons to use a statistical approach in analyzing this? The main benefits are that, for one, it is fully replicable, and then additionally, it provides an assessment of the strength of the data sample. Basically, as archaeologists, we have very little control over what our final data set looks like. We're forced to work with what we have. So we have to evaluate whether what we're actually able to collect can support our assertions about what we're observing. There are some shortcomings. Statistical approaches are only as valid as the data that is provided to them. They can't account for the context of the data on its own. When you apply a statistical method, you strip out all of its context. There's nothing inherent in the way that these tests work that controls for that. So we have to be extremely careful about how we're applying these methods, and we have to really understand how they relate to the reality of what's on the ground and how that might produce errors in our understanding of the thing. Okay, I was wondering where my presenter notes had come out of this. Let's just scroll all the way to the bottom. So, okay. So one thing about retaining the null hypothesis, which is that basically when a statistical test fails to identify a difference between the two samples it's evaluating, or many samples it can be evaluating, this isn't proof that there's no difference between those samples. It's just a failure to identify a difference. So it remains possible that there is a difference. We just need to find it in another way. Additionally, statistical tests never provide any absolute proof of difference. They provide a probabilistic proof of difference. And the sort of a standard baseline for accepting a statistically significant result is a 95% chance of that difference being actual. That's semi-arbitrary, but it's a 1 in 20 chance basically, and that's viewed as acceptable. And that's the standard that I've used in this analysis. So the basic questions then that we can actually apply statistics to, stepping back from the higher interpretive ones, are how does the distance between sites and water change? How does the distance between sites and their nearest neighbor change? And how does the regularity of site agricultural territory change as modeled here using the Thiessen polygons? These are two maps of the modeled hydrology of the Erbial Plain corresponding to each of the two periods we're analyzing, with site locations marked as dots. Sites nearer to water are in blue and grow increasingly yellow as the distance to water increases, with sort of gray in the middle. So detecting any change by visual comparison is difficult and prone to error. I mean, they just look like random scatters to me, which is exactly why we need to examine these from a statistical method. When we did so, controlling for the increase in the number of sites between the Bronze Age, Late Bronze Age, and the Iron Age, because it is a substantial increase, what we found is an increase in the proportion of these sites that are further from water. So this is a little more evident by looking at a paired bar graph. It shows on the left side the Late Bronze Age and the right side the Iron Age. And what we're seeing then is that this increase in the average distance between sites and water is driven by an increase in the number of sites between about 500 and 2,000 meters from natural drainages, whereas the number between 0 and 500 meters is about the same. So these more distant sites are basically the bulk of the new sites within this period. You have some resettling of older sites and abandonment of current sites, but the major increase is at that distance. So we use the same method to look at the North Jazira. The increase in the number of sites is far more dramatic here. It's about triple. But despite that difference, we found no significant change in the difference between sites and water within the distribution. So you only have an increase of site density at all distances from water within this region. Here's the paired bar graph for this again. As you can see, I mean, that difference in the number of sites is really evident, but the shape of the distribution itself, the sort of amplitude is larger, but the actual geometry is similar. So the conclusion as relating to this sort of planned landscape model is that any top-down planning that may have occurred in the Iron Age settlement of the North Jazira didn't target areas either nearer to or further from water. So to move on to this sort of nearest neighbor distance, the distance between sites and their nearest neighbors, one way to quantify that is just to build out these randomness dispersions. So these are idealized models. They aren't actually any part of our data set, but they show in a dispersed distribution you have significant distances between sites and their nearest neighbor moving through random, where there's a mix of distances, and then when you get to cluster, all their nearest neighbors are within the same little bunch. So those distances are very small. Randomness is difficult to evaluate by eye. We saw that on those pictures earlier. So looking at this distribution of site distances, this being the EPAS area, but the NGP area, which are looking very similar, we can find no significant change in the variability of those distances between the Late Bronze Age and the Iron Age in either region. In other words, they're similarly clustered or dispersed. To move on to this sort of idea of a site exploitation area or territory, the NGP and EPAS projects have both previously used Thiessen polygons to approximate this, where basically these polygons divide a large area amongst a set of predetermined points by delineating the sections that are nearer to a given point than they are to any other. So in using them to model settlement territorial extents, it's basically just dividing up the territory by proximity. So here are maps of the Thiessen polygons of the EPAS project area. The Thiessen polygons that are contained fully within the survey area have been shaded in green in order to indicate their total area, with dark green being smallest and the sort of trending to white being the largest. The size categories are scaled independently between the two periods, meaning that these numbers are not all exactly the same, but the reason for that is we're trying to look at the relationship in the sites within each period. When you have with the larger number of sites in the Iron Age, they're all necessarily smaller in area, but that's not exactly what we're looking to examine. Polygons that overlap the edges of the survey area have been left out of the analysis because they're more susceptible to edge effects, basically. A site being right here would substantially impact how these are shaped. We found that the general decrease in polygon size caused by the greater number of sites in the Iron Age impacted both small and large polygons equally. So there's not actually a change in the nature of the distribution here. Looking at the North Jazira, we see essentially the same pattern. The reduction in size is far more dramatic, but the relationships in size between the different polygons are roughly the same between the two periods. So while this analysis using Thesan polygons didn't find any indication of change between the two periods, as I said earlier, that isn't proof that there isn't a change. So we can look at alternative methods by which to quantify these territorial areas or agricultural exploitation areas. So work by Michael Crisholm and Tony Wilkinson showed that settlements like these exploit an area within a certain radius of themselves. Many of our Thesan polygons, I'll actually go back a bit, clearly they're substantially elongated and clearly are going to include areas that are outside of that exploitation radius. So if settlement patterns or settlement locations are planned under this model to maximize the amount of land within the exploitation radii of the entire set, we might expect them to be an approximation of many circles packed together in sort of an orthogonal pattern or like a honeycomb hexagonal pattern. So these are sort of two idealized examples of the way they might tessellate, but we might try to analyze the way in which our Thesan polygons approximate that. That is something for future work. So for now, we're just using the Thesan polygons to get a set. So basically, the results of this analysis are during the Iron Age, the proportion of settlements at greater distances from water increased on the Erbil plain, but not in the North Jazira. This is despite the fact that North Jazira saw a far greater increase in the total number of sites as compared to the Late Bronze Age. In neither region was there a meaningful shift in the pattern of distances between settlements and their nearest neighbor, and the sizes of settlement territories as modeled by Thesan polygons were similarly variable in both regions when comparing the two time periods. However, there are all of those issues with that metric as to whether it is meaningful. So the most robust conclusion that we can really draw from our data is that the Iron Age settlement increase in the North Jazira did not involve expanding into hydrologically marginal territory in the way that expansion on the Erbil plain did. Given the number of sites in the North Jazira, that's a huge increase in density as compared to the past. There are a lot of ways that one can interpret this phenomenon, and there are more variables that can and should be analyzed in the construction of a full model, but for now, we can suggest one possible factor may be a change in fallow cycle practices. So in their monograph summarizing the results of the North Jazira project, Wilkinson and Tucker described the importance of the fallow cycle in ensuring the productivity of each year's cultivated fields, alternating between cultivation and leaving the field uncultivated on a biannual cycle. So Neo-Assyrian legal documents detailing the sale of agricultural lands corroborate the use of an on-year, off-year fallow cycle in parts of Upper Mesopotamia, and by describing it as sort of sold in pairs. But it may have become unnecessary to leave fields fallow in the North Jazira during this period because the onset of the Iron Age coincided with a 2-century increase in winter rainfall. It is roughly equivalent to the water amount that is retained in a fallow year annually. So if you have this climatic shift, allowing agriculturalists to effectively double the amount of land they're cultivating every year, that would explain why these new Iron Age settlements, or could explain, are filling in the gaps, essentially, between our late Bronze Age settlements. The exploited territory around each site, assuming they're not growing in population enormously, is essentially contracting. They can rely only on the fields that are closer, and now you have all these spaces in between them that people coming there can decide to start farming themselves. So if this interpretation is correct and there is this abandonment of fallow years within the North Jazeera, then if we're working under this planned landscape model, it might suggest that the Neo-Assyrian government officials who are responsible for determining how to maximally exploit the landscape were responsive to local climatic conditions, adjusting their strategy according to what is actually best suited to where they are rather than the entire region as a whole. So moving forward, this approach will involve continuing to work on these questions and pursuing new ones to which statistical methods like these are applicable. It'll require refining the methods we've already used and adapting others to the nature of the data as it is developed. And as EPAS and other projects further expand landscape data sets, these statistical analyses will grow increasingly robust in their ability to contribute to landscape research. So I'd like to thank all of the individuals and organizations responsible for supporting this project, as well as our Kurdish and international team members.